In this video, we're going to introduce workflows in RAMP. Workflows allow you to sequentially chain together readers, writers, and processor methods. The Workflow tab within the RAMP GUI allows you to generate and plan out your workflows. But first we need to understand some basics about processors, readers, and writers in RAMP generally. So every processor requires an array of raster inputs and generates an array of raster outputs. Even if that particular processor method doesn't actually generate any rasters or actually consume any rasters, it's still a requirement of executing a processor method that there are a series of input rasters and a series of output rasters. Now, those arrays can have nothing in them and they can be null, but it's a requirement that that's how processors can communicate with each other. And so the same is true for readers and writers. Readers and writers in the context of a workflow take a raster array as an input and generate a raster array as an output. So this is fundamental to how you chain together processor methods, readers and writers in the RAMP workflow environment. Let's do an example. So here I am in my workflow tab, and if I right click in here, I'm going to add a reader. So this is no different than the reader that you would be accessing from the graphical user interface, but it's now available as a workflow item. So let's choose my favorite data set here, and it's asking me, well, what format is that file? Well, it's a bill file, and it's asking me what my output is. So this is going to be a name, and this needs to be a variable name. So it needs to follow the naming conventions, the best practices for variable naming conventions. So it shouldn't have funny characters in there. It can have underscores, it can have numbers in there, but generally it should be alphanumeric, and it certainly can't have any spaces. Okay, so I've created, I've read in this bill file and I've told it it's a bill format, and I'm going to output it so that it's available to the workflow using the variable name Bathy. Now remember what I said earlier. Everything that goes in and out of a reader, writer, or processor method is actually creating a raster array. So in fact, Bathy is a raster array. In this case, it's actually only going to have one item in it because a reader only reads one file and generates one raster output. Okay, so in this example, we're going to go back to something we did earlier where we want to identify the spatially localized range in a data set. So what we're going to do first is we're now going to add a processor. And it's asking me, well, what processor do you want to use? Well, I'm going to use one of the local statistics processors, and I'm going to use the max method. So this returns the localized maximum value within a specific kernel. Okay, it's asking me for my input. So my input needs to be Bathy. Yep, and it's asking me for an output. So I'm going to call the output max of Bathy. That's a sensible naming convention for the fact that we're calculating the localized maximum in a kernel. And then it's asking me the same things that the kernel process, the same things that you would be asked if you were to execute this in as a normal processor method. What is my input raster index? Well, that simply is index number 1 within that input Bathy. So it's asking me for what raster do you want to use within that input. So I know that Bathy only contains 1. So the answer is input raster index number 1. And then it's asking me for the kernel size. So I'm going to use a 9x9 kernel, and I won't specify a kernel definition file. And I'm going to do the same to calculate the minimum. So I'm going to go to my local statistics. I'm going to choose the minimum method. And it's asking me again, well, what's your input? So my input is also going to be Bathy. And my output, I'm going to call it min of Bathy. The input raster index is the number 1 raster within that Bathy raster array. Again, the kernel size is 9, and I'm not going to specify a kernel definition file. Now I'm going to add another processor. So that processor is going to be the map algebra subtract. So it's asking me, what are your inputs? Now, I have existing arrays available. You'll notice I've created the Bathy raster array, and then I created max of Bathy and min of Bathy. However, I need to have 2 inputs for my subtract function. I need to be able to subtract max away from min. So I need to create a new array that contains the rasters within this array. So I'm going to create a new array, and I'm going to choose the first raster within the max of Bathy raster array, and then the first raster within the min of Bathy array, and those are going to be the 2 items in my new array. So I'm going to click OK. And then it's asking me for an output. So I'm going to call this range of Bathy. And it's saying, well, what do you want to use first? Well, I want to use max of Bathy first, so that's number 1. And my second will be the second raster here, the min of Bathy. Okay. And lastly, what I'm going to do is I'm going to write this out to a file. So I'm going to add a writer. So I'm going to choose the range of Bathy at index position number 1. And I'm going to tell it to write the ramp binary format. And I'm going to output it to workflow.ramp. There's a file I created earlier called the same thing. Okay, so this is a very simple workflow that we've created using the workflow editor in RAMP. I'm just going to quickly talk about a few other things. So if I am not sure about, say, the range of Bathy processor method, if I click on this particular icon here, it takes me to the help file for it. The same is true for, say, let's have a look at min of Bathy. It takes me to the help file for that. If I decide to remove a step, I can click on the X here to remove that step. I can also change the order of steps. So for example, I might choose to generate the minimum before the maximum. So to do that, I click on the up arrow here, and now you'll notice that the minimum is calculated before the maximum. Okay. The order in which I use the variables is also important. So for example, if I tried to calculate the range, put that at the top, it's now said, hey, look, this is red. Max of Bathy and min of Bathy don't actually exist yet. And if I try to pick it, you'll notice they don't exist yet because this is all calculated or executed sequentially, and I haven't yet created max and min of Bathy. So let's put that down again. We'll get the max to go first, back to our normal range. Okay, now what we can do is we can save this workflow. So I'm going to save it to a workflow file, workflow.rwf. I can choose to save it to a different file if I want to. Yes, this is now saved the workflow so that I can use it again at any point in time and restore it. Okay, so let's run this and see what happens. Now it's important to note that when I run a workflow, it actually runs in a separate process outside of the RAMP graphical user interface. So if you've got a long running workflow, that's great because it runs separately and it doesn't stop you from working in the RAMP graphical user interface. So let's run it and see what happens. So here it is running and it's stopped. And the reason it's disappeared is because there were no errors, everything worked fine. Let's go and open the file that we created, the workflow.ramp file. Add, looking for a ramp file, workflow.ramp. And here it is in the GUI, and it's as per the previous times we've generated this range raster in other videos. So when I told the workflow to run, it actually was running it in a command line interface. So let's look at how we can run a workflow file that we've previously defined from the command line. So I'm going to go to Tools in here and the command line interface and double click it. Launch CLI. And this has launched a command window, and it's taken me conveniently to the location where my ramp binary files are. So if I, whoops. If I look at my executable files, I have my ramp GUI in here, I have ramp profile, and I have ramp processor and ramp flow. Ramp flow is the utility that executes workflow files. So let's just type ramp flow, and it's saying, okay, well, you need to pass me an argument. Okay, so ramp flow, and it wants to know what the work file name is. So there it is, ramp flow, blah, 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 blah. I have a number of other options as well. I can say, I can tell it to write to a particular log file. I can tell it to force an exit at the completion of execution. I'm not going to do that. And I can specify if the log file should be appended to. So if I'm running a series of processes, say, as a cron job or as a batch script, then I can get it to append to a log file and I can monitor that log file. We're going to do something simple. We're just going to execute this and see what happens. And you can see it's basically executing that workflow, and it's completed and done. Let's just go back to the ramp GUI and the workflow editor and look at what prompt does. So if I had chosen for this input to tell it to prompt, it's going to ask the user to define that input file. So it makes that input file variable to the user, so that when I run this now, so let's save this workflow, save. When I run it again, it's asked me, oh, tell me what input file you want. So we're going to go to sample data, and we're going to look for my favorite, which was this one. And I've defined it, and now it's going ahead and executing the rest of the reader. Sorry, it's asking me what format it is. That popped up on my other screen. And it's going through and executing the rest of the workflow. So that's what prompt does. And I can use prompt on anything. So I could ask the user to prompt for a kernel size. So let's do that. Let's fix that, but let's change the kernel size. And we're going to prompt both of these. So we'll save this workflow, and we'll run it again. Now it's saying, what property size do you want? So let's do a 13 by 13 kernel. And it's going to come up and it's going to ask me for the next one. Yes, that's also a 13 by 13. So I can prompt on anything and have the user react and add those variables to the workflow. Okay, let's look at one of the other types in here. So you'll notice that I can add a reader and writer. We've done that, and we've added processor methods. There's also an option here to release memory. So let's add that and find out what that does. So release basically means that if you have a raster, for example, that you're not using anymore, you can release it from memory to save the amount of memory that's being used by your computer. So for example, in this case, I might put the release a bit higher up the list. So I've calculated my max and my min from Bathy. I no longer need the Bathy raster array variable anymore. So I can say, hey, release that, release Bathy, before you go through and perform the subtraction method on the max and min. So that's what release does. It just is a way of releasing memory and making things a little bit more less memory intensive for the processor. The other thing I want to mention is what happens if we were to add, so let's add another processor in here. And that processor will generate the statistics for a data set. So generate raster statistics. And again, it's saying, well, what raster do you want to use? So let's use the range of Bathy. Yep. And it's saying, well, what output do you want to give it? Now we know that this particular processor method doesn't generate any output rasters. So I just need to give it a name. So I'm just going to call it no data raster. Yep. And that satisfies the requirement that I have to specify inputs and outputs. This is not going to have anything attached to it, but I have to specify an output, regardless of whether we know there are outputs or not. Okay, so that's been a quick introduction to workflows in RAMP. I hope it's been useful to you. We're going to have more videos that explore how to export workflows to different types, so batch scripts or Python scripts or even entire applications. So we'll look at that in another video. Thanks for watching.